simplify algebraic fractions by factorizing the numerator and denominator and cancelling out fractions. That's what we practice, alright? That's what we always do. Okay, but in the past what we've been doing with simplifying fractions is doing it with only numerals or just single pronumerals. Okay, cancelling out x squared and x, or cancelling out this and that, whatever. Alright, but now we're getting on to, well, we know that we can have binomial factors, as in something in brackets. And so we're able to cancel those out as well by factorizing expressions and using these tricks we've learned to do that. So let's have a look at some examples. First one is quite straightforward. So we have this thing 8 over 8x plus 8y. Now, can we factorize the top? No, it's just a number. You can't factorize. It's as simple as it can be. However, we can factorize something in this fraction. What can we factorize, and how do we do it, Josh? It is. You can. So we say, well, it's a common factor of 8, so we do 8 over 8. What goes in the brackets? X plus y. Right? Now then we can see something here. Nina, what can we see about this fraction? 8. You have a common factor on top, you have a common factor on bottom. Which means they what? Add. Right? What do the 8s do? They cancel each other out. That goes away, that goes away. And so we're left with 1 over x plus y. Much nicer and neater than 8 over 8x plus 8y. Okay. And if you did more operations and did more things with this, it'd be much easier to use. Do things. Okay? Any questions about that one? That's just a straight factorizing the way we used to. Okay? Now we have this one, r squared minus 25 over r plus 5. Can we factorize the denominator? The denominator, which is the bottom. Can we factorize it? R and 5. Any common factors? No. There are no common factors. However, the top expression, what is this type of expression? It's the difference of two squares. R squared minus 25. R squared is a minus sign. 25 is 5 squared. Hence, it's the difference of two squares. Anyone not see that it's the difference of two squares? Yeah? You can ask and clarify with me. So what happens is, how do we factorize the difference of two squares? R squared minus 25 would become r squared minus 5 squared. That's true, you could write it like that if you like. R squared minus 5 squared over r plus 5, excuse me, equals, good to see, I'm someone else maybe. I'm not the person I'm going to do, but Brittany, tell us.
You're very like factor is like 5.
Yeah.
And then you bracket r plus 5. Then association r plus 5. Good. R plus 5, r plus 5.
Good.
Yeah.
Excellent. Well done, Brittany.
Bracket r plus 5. And then you can cancel it out.
Yeah, you are. Go.
All
Alright? So what cancels out? The common factor of r minus 5. R plus 5, sorry. You got r plus 5 on the top and r plus 5 on the bottom. They both cancel out. R plus 5 divided by r plus 5 cancels, and so we're simply left with r minus 5. Alright, so it's a nice thing when we can factorize using these methods. Something that looks kind of complicated and a little bit difficult to handle collapses down and simplifies to r minus 5. From here, yeah, that's an intermediary step. People maybe need to see. This is a step that you want to skip over soon enough. Okay, one, you're getting used to it, and you want to see what the two squares are. that step's fine. But go from here to here. Yeah, you should be able to just see straight away. Okay, R minus 5 plus 5. You can just see. Okay, that's what I said. I'll say it again. We're looking for fluency and increasing your ability to see things and to apply things quickly. Okay, so it's not rushing, but the skills that we need to get good at, you're using. So it's like second nature. So you just say, oh, I can see that. That's different squares. And then after you apply that, and you can see it. All right? Any questions about this one? We're good? Give you 2 seconds to write it down if you haven't already. Right. I wouldn't write it too much about the writing. We've written that stuff before. Okay? Yes? Yes? Close. All right. Let's go to the next one. Here we have y plus 1 squared over y squared plus 4y plus 3. Now, can I suggest this to you? When you see something like this, often the impulse is to expand out the brackets. Okay? But generally speaking, this is not always the case, but generally speaking, when you have expressions like this, you want to factorize things rather than expand things out. Okay? You're looking to factorize things because there you get things factored in brackets, which then hopefully will cancel out with each other. If you expand all this out, you're going to have a bunch of y squared terms, y terms, constant terms, with probably no common factor which you can cancel out. Okay? So that means that I'm going to, what am I going to do to the top here? What should I do to the top? Cooper? I should leave it alone. I'm not going to expand it. Because expanding it will actually make this more complicated and more difficult to handle. So I'm going to leave the top alone. So that's just y plus 1 squared. I'm going to leave. Now, we have to factorize the denominator. Yes, Kevin? It is a quadratic trinomial. Good. How do we factorize a quadratic trinomial?
We have to find the middle plus the number outside.
Yeah. Which is a 3. Okay. Good. 2 numbers. Excellent. So, again, if you can skip writing all this and just see that this is 3 and 1, then that's a great thing. Okay? So if you need to take time, that's fine at this stage, but your goal is to recognize it and be able to take that step. So 3 plus 1 is equal to 4. That's the middle number. 3 times 1 is equal to 3. So the numbers are 3 and 1. Hence, this becomes y plus 3, y plus 1. Sean, what do you notice about the top and bottom here? Numerator, denominator. No, there's something similar about it. Yes, I'm looking particularly for. They both have y plus 1. So what happens to those y plus 1? What can happen, Cooper? Yeah, that's right. So this one is y plus 1 times y plus 1. So I'm going to cancel that out. And that no longer is squared, it's only one lot of y plus 1. So I go to y plus 1 over y plus 3. So again, factorizing it has helped me to go from something that looks like this with all squares and things to go to this, which is nice and simple and much more easy to manage. Yes. Good question. Who can answer Cooper's question here? Adam. No, why not? Why can't you cancel out the y? That's a very good question. Why can't you cancel out the y? Yeah, essentially that's right. Y is not a common factor to the expression on top or the bottom. Y is only one of the terms. Right, so I can't just divide, I can't just cancel this one out and be left with 1 over 3. Okay, if you think of it numerically, 3 plus 1 over 3 plus 3 is 4 over 6. That's not the same as 1 third. If I just cancel out the 3, it wouldn't work. So it's really important that when you have an expression with y and y, or x and x, if it's x or y plus something, if they're not exactly the same, you can't just cancel out the y's. Okay? It has to be a common factor on top and bottom. That's why it's really important that you factorize top and bottom first, and then cancel out. Yeah.
So what if the top is in brackets and then the bottom is then top, then have like times 3?
Yeah. So for example, if you had y plus 1 times 3, something like that, do you mean? Yeah, then that's a common factor because you're multiplying. So that is equal to 1/3. Okay? But that's a very different case. You're not adding, you're multiplying them together. Okay, so that's different from that. That's a special, that's a different case altogether. Yes?
So if the top and the bottom are exactly the same, you just write them equal.
Yeah. Yeah, if the numerator and denominator are the same, you're dividing something by itself, which means that it's 1. Okay? Right, let's have a look at this one. What do we have here on the top and the bottom? Trinomial, yes? Okay. So what do you have to do to the top and the bottom? That's right. You have to find two numbers for each. And because there's a coefficient of x squared, we add an extra step. Right, so this one is reasonably a little bit work intensive. But, so the top, let's look at the numerator. So we've got 60. So two numbers. Okay, sum of minus 7. Okay, minus 7d. And they have a product of 6 times 2, okay, which is 12. 6 times 2, which is 12. So the product is positive. The sum is negative. So the two numbers are going to be what, Andy? Yeah, two numbers negative. Do you know what the numbers are? Oh, yeah. Oh, this? Oh, that's just the example that Matt asked about. If you have two of the things that you multiply by something, you can't cancel. What are the two numbers, Daniel? Good, excellent. -4, -3. Okay, -3, -4. That's correct. So I can divide the top of this 6d squared minus 3d minus 4d plus 2. That's my first step. Now I have to work out separately the denominator. So for the denominator, denom, we have to sum to 9 and have to multiply to minus 10. Product of minus 10. Because it's 2 times minus 5. So they add to 9, multiply to minus 10. What are the two numbers, Josh? It is 10 and -1. Good. 10 and -1. So again, I'll divide this up. I'll go 2d squared plus 10d, minus d minus 5. Questions about this step that I've taken? Right, I've just done the top and the bottom separately. I've done the numerator. I've split it up to -3 and -4. That's what 7d is. And then the denominator, split the 9d up to 10d minus d. Good with that? Sure. Alright, just again. So I'm going to move this over here. Now we have to factorize in pairs. Yes, Anne, question? Because the two numbers that add to 9 and multiply to minus 10 are 10 and minus 1. Yeah? So that's the way of finding these numbers. Now I'm going to factorize top and bottom in pairs. So after 6d squared minus 3d, the common factor is 3d, d minus 1. Alright, for these two I'm going to take out a factor of minus 2, and I end up with 2d. Oh, so that's 2d minus 1, minus 2. That should be 2d minus 1. 2d minus 1, and then I take out minus 2, 2d minus 1. Questions about how group these and factorize them? Have a look. Make sure you're following what I'm doing. Okay? I've taken out a factor of 3D from the first two. Taken out a factor of -2 from it. Expand it back and see whether it's correct. Yeah, I'm just doing the numerator first. That's the numerator.
So you can't like do the 16 squared budget over 3 days, but you can't do what 16 squared over.
No.
You can't.
You can't split it up. It has to be kept together. Yeah, because otherwise it's not proper. Yes. Yeah. Because I've taken that step because I want to get this to be 2D minus 1, just like this one. If I left a negative in, this would be minus 2D plus 1. Yeah? And I want to switch the signs so they match up. So that's why I've taken the negative. This one? Because 3D divided by 3D is minus 1. And 2 divided by minus 2 is minus 1. I've taken out those factors. Alright, now let's factorize the bottom one in pairs. I'll take out a factor of 2D. And so you get D plus 5. And then the second pair, I'll take out minus 1, D plus 5. Alright, you should be at this stage seeing what's happening. And so the top is going to go to 3D minus 2, 2D minus 1. And the new denominator is 2D minus 1, D plus 5. Alright, what cancels out is this one. That cancels out, that cancels out. And so what we end up with is 3D minus 2 over D plus 5. Question. Using exactly the same thing as we've been doing. How to factorize quadratic trinomials? It's exactly the same. You're just doing the numerator and denominator separately. Once they're both correctly factorized, if there are any common factors, you can cancel them out. Right, so try not to, you can't cancel too early. You have to factorize first and then cancel. Yes, Anne? Yes. Yes.
In the second half step, how did you get this one to be like that?
This one?
Yeah.
Okay, so this one, if you look at the top, I've got 2D minus 1 is a common factor for both terms. So I've taken that out, and I'm left with 3D for this one, minus 2 for that one.
So when you do that, you just keep, you cancel it out, but you keep one of the, like, you put it in the...
Yeah, I mean, you're taking out a common factor. So 3D, 2D minus 1 is this one, as if you're expanding it, minus 2, 2D minus 1. That's right, you go to the next one. Yeah. The same with this one, that's a minus 1. Okay? Let me just stop the recording quick. Exercise 3.12 is practice.